In this lesson, we're going to focus on three aspects. Basically, we're going to work with visualization to explore data. So we're going to look at some different kinds of plots and look at different ways we apply those plot methods, those visualization methods, to dig into a data set, explore the data set, and deeply understand the relationships between the different variables in that data set. So what is exploratory data analysis? So the idea is to explore the data visually, to understand what's going on. You want to understand the relationships in the data, which variables might be collinear, they may just be redundant, which variables seem to, or maybe I should really say features, really seem to vary with the label we're trying to predict in some useful way. And to do that, you generally wind up creating multiple views of the data. You don't want to just look at, say, one set of histograms or one scatter plot or something like that and say, okay, yeah, I kind of understand this. Because you probably don't. There's probably, if the data is at all complex, and real-world problems are inherently complex, you will find that multiple views will elucidate what's going on there. There's also a fundamental problem in graphics that you don't know, or you have many dimensions, and you don't have a way to sort of fly through them. You can look at. There are some packages that support things like rotating scatter plots and things like that, but it's still limited. So there's a number of tricks we use, and one of them is aesthetics. So by an aesthetic might be color of the points on a plot or something like that. So by adding aesthetics, we are able to project more dimensions. Another method we're going to talk about for projecting multiple dimensions is the idea of conditioning. We've looked at this a little already, but I'll go into much more detail here. How do you use conditioning variable to take your two-dimensional surface that you're looking at, say on your computer screen, and be able to look at 3, 4, 5, or even more dimensions? And the other thing to use exploratory graphics for is sometimes it's very useful if your model isn't working, if something's strange going on, that you're consistently getting the wrong answer or something like that. Understanding the sources of model error can be a really useful application of visualization. And let me just add a historical note. So the idea of exploratory data analysis, or EDA, was developed starting in the 1960s by John W. Tukey at Princeton, and he wrote this seminal book, Exploratory Data Analysis, which was published in 1977. I was fortunate as a graduate student to actually work a little bit with John Tukey, just ever so briefly, but it was a really amazing experience. So let's talk about views of the data. And what do I mean by views of the data? So as I've said, you're trying to get at those complex relationships that no one projection can get at. So we're going to look a couple different ways at the same data, and it may seem redundant, but sometimes it's very surprising what comes out of that. And they can, different views can reveal different aspects of the relationship. So you may see using a certain set of aesthetics, like color for the points might show one thing, using some set of conditioning variables might show something quite different. And different plots highlight, different relationships. That's really what the point of the different views are. Just not assuming that one view or one small set of views shows you everything you might want to know about that plot, or that data. And so what are some different plot types we might use? Scatter plots, we've already looked at those. They're pretty basic. A scatter plot matrix, which I'll talk about, is another way to employ scatter plots. Line plots, which are sort of a direct relative of scatter plots for some cases. Bar plots, histograms, which we've talked about, and also a relative of bar plots, box plots, which we've used already, and another relative of the histogram and the box plot, the violin plot. And finally, QQ plots, so where you can look at quantiles of a distribution to get some idea of like a fit to a distribution or something like that. So let me talk about aesthetics here. So the idea, as I've already indicated, is to allow the projection of additional dimensions from your two-dimensional surface that's your computer screen. But don't overdo it. I've seen cases where people use so many aesthetics on a plot, and you study it, and you really have no idea what they're trying to highlight because there's so many things going on in the plot. It's just completely overdone. So you got to be a little careful with this. So one of the common aesthetics, and one that's generally pretty effective, is color. Do be, if you're one of the people who are colorblind, or if you work with people who are colorblind, you need to be a little sensitive about what colors or shading might actually work for those people. Shape, like shape of a point on a plot, can be useful. But again, if you get more than 5 or 6 shapes going on a plot, in my opinion, it starts to become very hard to tell, a little star from a little dot from a little triangle or something like that. So don't overdo it. Size is a tricky one. You can make the points, or the shapes larger and smaller based on the value of some other variable. And if it's very definite, that you have certain big ones and certain small ones, shape or size can be quite useful. But size is very deceptive. And also, when you think about size, are you talking about area of the plot, or say diameter of a point around circle, or the diagonal across a square shape, or something like that? And the human perception of size is not very precise. So do be careful about that, and think about, are you trying to show area or some sort of linear dimension, or what? Transparency is a useful aesthetic, because when you get a lot of plots on your two-dimensional surface, they can lie one on top of the other, and a little bit of showing some transparency, so you get some see-through and can kind of see, oh yeah, there's a lot of points piled up there. Again, it's a little subjective, but it can be helpful. And then there's aesthetics that are specific to specific plot types, and I'll show a few examples here in a minute. So let's look at a scatter plot. Very basic. We've already done this a number of times. This is one I think we looked at before. Price versus city miles per gallon from our automotive data set. So you can see, like all scatter plots, we have a vertical axis with some scale and a horizontal axis with some scale. All right, fair enough. And then we've got our points. But let's apply an aesthetic to that. So let's try a larger point size. So, okay. So now you can see the clustering of the points a little better. I haven't tied that to any particular variable. It's just a larger point size. But we could do that if you wanted to, or you could do that if you wanted to. Let's look at adding color now to that plot. So we're adding another aesthetic. So we've increased the point size. We're going to add color. So our color here tells us whether the engine in that automobile is a standard or a turbocharged aspiration. And it's a little hard to make out what's going on here. You see the kind of bluish green shapes are the turbo cars. So what they all sort of are in the middle here. They're surrounded by a lot of other automobile. Not entirely clear what's going on there, but maybe something. So let's add another aesthetic. Let's add shape here. In this case, the shape is a round, or sort of almost a diamond for diesel and a triangle for gasoline engine. And again, the color red for standard and this kind of greenish for turbo. And now we can start seeing, okay, so we've got a lot of turbo diesels here. They tend to be more expensive for the mileage achieved, which is kind of interesting. And then the turbo gasoline engines tend to be at the high end of miles per gallon and out here in price. Now we could continue to add aesthetics or other things to this plot to try to understand that. But just by adding 2 aesthetics to this plot, we've learned something interesting, that turbo diesels, first off, most diesels seem to be turbos, and turbo diesels are more costly for the given fuel economy. And finally, let's add some transparency. We had a lot of points piled up there, and now you can start to see where they're really clustered. You can see through and see that, yeah, there really are a lot of cars in some of these categories here, especially of the gasoline engine cars at certain price ranges, certain fuel economy ranges. Notice also that fuel economy is reported, I believe, in integer units, so that's why they pile up. Another aesthetic could be some dithering, so that these points were a little bit side to side, so we're not exactly on the miles per gallon. So another approach to scatter plots is a scatter plot matrix, and here's one. And how do you read this? So down the diagonal here we have the feature, the variable. So we got actually, well, 4 features. In this case, price is our label, we've said, for this data set. We're trying to predict price. And we can see multiple relationships of price versus miles per gallon. And with the axis flipped, see it's symmetric across there. Engine size with price. Curb weight with price, so heavier cars being more expensive, and length. So it looks like on average a longer car is a bit more expensive, but that's not a really definitive, just like a heavier car tends to be more expensive. But you can also start seeing things like engine size and fuel economy have some kind of relationship, and weight and fuel economy have some sort of relationship. And less so, say, with fuel economy and the length of the car. So there's a bit of a relationship. I suppose longer cars are heavier, and we can look at that here. Yes, longer cars do seem to be heavier, but the relationship kind of breaks down for fuel economy. So you can learn a lot about a scatter plot just by, by studying it a bit, and they're fairly easy to make in R or in Python. So let's look at a line plot. So a line plot, as I said, is a cousin of the scatter plot. But in this case, this is a time series of milk production in the state of California. That's the black. And if you just showed the points, it would, they'd go up and down, and you'd really have to study it. So this way, we've connected the points with a line. That's all a line plot is. And actually, I've suppressed the points in this case because they just added clutter. So we can look over these years and see that there's kind of an annual cycle of milk production in the state of California. And then I've added another line plot, the red, which is a polynomial fit to the trend. So a number of ways. You can add a line plot with trend, say, to a scatter plot. That can be a useful exploratory technique as well. So bar plots. So here's your basic unordered bar plot. And a bar plot is generally done, or is always done, with discrete values. So categorical values, probably. For example, these are number of patients that get admitted for a diabetic condition, as it turns out. We can see that circulatory problems are the #1 reason. But you kind of have to look at this and think about it. What's the #2 reason? And if I look, and I think it's endocrine, because that's slightly higher than respiratory, which seems to be 3rd, and then maybe digestive is 4th. And it starts to get harder and harder to see which what's the order of importance of why these patients were admitted to the hospital. But we can also do an ordered bar plot. So that's a specific aesthetic for a bar plot, is ordering the bar plot. And now it's pretty easy to see that circulatory, followed by endocrine, followed by respiratory, followed by digestive, etc., are the reasons that diabetic patients are admitted to hospitals. So again, just a simple aesthetic, just ordering the plot makes it a lot easier to interpret and understand what's going on here. So let's look at a histogram. We've talked about histograms. Obviously, there's bins on the horizontal axis for a range of the values, in this case, automobile price, and the count or number of automobiles in that bin on the vertical axis. And in this case, I've done this with 20 bins. You can see the bins are pretty wide, and it kind of tends to smooth the histogram using wide bins. But what if I tried, say, 60 bins? That's a different aesthetic. Well, now my histogram looks a lot more jagged, goes up and down, and you can see that what's out in the tail are just a few discrete values here and there. So what's right? Well, it depends what you're trying to present, what you're trying to understand. But keep in mind that just changing that simple aesthetic of how many bins in your histogram has a big effect. Box plot, we've talked a lot about box plots. And just to remind you, the dark line here is the median. This is the first upper quartile, the first lower quartile, and the range on the whiskers, from max to min, and some outliers here, okay? And here we've grouped the box plot by diesel or gasoline engines for the automobile price. And you can't tell a whole lot from this. So diesel, yeah, maybe they are the median price of a diesel car and the upper quartile of the median of the diesel cars are a little bit more, even the lower quartile. So, you'd say, well, yeah, maybe diesel cars are just a bit more expensive than gasoline cars, but it's not dramatically so. But if we look at the number of cylinders, so it's a different aesthetic, a different grouping, we can see that, wow, 8-cylinder cars are really significantly more expensive than 6 cylinders, except for a few extreme cases, or 5-cylinder, and 5 and 6-cylinder cars, well, they overlap a lot, but they're clearly, for the most part, more expensive than 4-cylinder. And then we get some odd things. I think there's just one 3-cylinder car and one 12-cylinder car, but you can see where those lie. So just by changing what that group by variable is, that aesthetic, now we get a different view of the data. It tells us a little more about, well, it doesn't have so much to do with the type of fuel the engine uses, but the number of cylinders has a big effect on the price of the car. A cousin of both histograms and box plots is this violin plot. And so this is a density, it's actually a density plot, and it's done symmetrically. And so now we can see that even though there's a lot of overlap between diesel and gas cars have this big hump way down here, and then it's a long tail of some very expensive gasoline cars, whereas diesel cars tend to be more compactly grouped here. Not a huge difference, but it is noticeable with the violin plot, just by changing from what we saw with this box plot, recall, which didn't look that different. And if we look at the violin plot, yeah, now we see something kind of more interesting there. Same data, same aesthetic, different plot type. So the QQ normal plot, that is, so what we've plotted is the quantiles of a sample distribution here and the quantiles of a theoretical distribution here. You can do this for most any distribution. In this case, we're comparing the quantiles of a theoretical normal to these data, and they should fall in a line. And if I put a line on there, yeah, it's pretty darn close to a line. We got a few outliers here that are up and down and a little bit of jaggediness at the end, but it's pretty close. But then I have another distribution, and that doesn't look like a line. It looks pretty different. So I can probably say at least in the middle, it kind of looks like a normal, but the tails really aren't like a normal distribution. So anyhow, I hope that has given you some insight into how we walk through, use different views to tease complex relationships out of data, some of the tools you can use, and some of the ways you might interpret that. And we'll get back to that with a bit more hands-on as we go through this course.